So this question says a student jumps vertically up off a diving board with a speed of 9 meters per second. The diving board is 4 meters above the water. And it asks various questions about it. Let's just go to our diagram briefly and recognize that that distance from there to there is 4 meters. And here's the student jumping up with a velocity of plus 9 meters per second. And there's various stages. At point A, they're on the diving board. At point B, she's vertically above the diving board. Stop going upwards, just about to start going downwards. Point D, she's somewhere in between the top part of her journey and been level with the diving board. At point C, she is level with the diving board. And point E, she is entering the water. Remember, the journey, any journey has to be constant acceleration. So for the overall journey, we talk about from the instant after she leaves the diving board until the instant just before she reaches the water. So let's see what the questions are. The first question says, what is her vertical acceleration at point B when she is stationary at the top of her journey? So she started going upwards and she slowed and slowed and slowed, and now she's stationary, and now she's about to fall down. And the answer to this is minus 10 meters per second squared. It's always minus 10 for the free fall. Free fall is when only gravity acts on her. So free fall is all the way up and at the top and all the way back down again. The acceleration is minus 10 meters per second squared. 10 meters per second squared pointing downwards, caused by gravity. Gravity is constant, therefore it's the same for any point. This idea about she's stationary at the top of her journey, that's trying to get you to say zero, because some people have the idea that if you're not moving, you can't be accelerating, and that's not true. So be really careful. Link accelerations to forces. And because the force of gravity is constant, so the acceleration is constant throughout this. What is a vertical velocity at point C when she is level with the board? So because we don't worry ourselves with air resistance, because we only deal with the acceleration due to gravity, what gravity takes away from our velocity on the way up, it gives us back on the way down. So there are symmetries here. And one of the symmetries is, for example, it takes as long to go from A to B as it does to go from B to C, because your journey on the way up is mirrored by your journey on the way down. And another symmetry is that the speed at A is the same as the speed at C. At A, the velocity is pointing upwards. At B, the velocity is pointing downwards. So I can say by inspection that the velocity at point C is minus 9 meters per second. 9 indicating that it's moving downwards. The negative indicating that it's moving downwards, and 9 being the magnitude. And then what is her displacement for the complete free fall journey? So let's be clear about that. She starts here at A, goes all the way up to B, through D, through C, and then finally ends up here at E. So the displacement is the final position minus the initial position, and her displacement is that, which is delta x, which equals minus 4 meters. Not 4 meters, and certainly not plus 4 meters. Her displacement for the entire journey equals minus 4 meters, because she ends lower than she started. So it's going to be minus 4 meters. So 3 questions answered really by conceptual information rather than mathematical information, rather than equations. Let's look at a continuation of this. This says a student jumps vertically upwards off a diving board with a speed of 9 meters per second. 4 meters, the diving board is 4 meters above the water. And it says, what is her vertical velocity at point D, which is 3 meters above the board? So that's 9 meters per second. That's a positive. And then we have this point here, and that is going to be my displacement. So I can say find VF. What is a vertical velocity at point D? Find VF. Let's make our list. We can say VI is equal to plus 9 meters per second. We can say that acceleration, of course, is minus 10 meters per second squared. We say that the displacement is, it says that this is 3 meters above the board. So her displacement is plus 3 meters. She ends higher than she starts. And she ends 3 meters higher than where she starts. So her displacement is plus 3. And we want to find VF. So I look at that, and the question I have is, what equation can I use? Let's have a look. VF squared equals VI squared plus 2AX seems like the best one. VF squared equals VI squared plus 2A delta X. Delta X being displacement. It's all one symbol, just meaning displacement. So VF squared is equal to plus 9 squared plus 2 times minus 10 times plus 3. So VF squared is equal to 9 9s are 81 minus 2 3s are 6. 6 times 10 is 60. VF squared is equal to, it's going to be 21. So VF is equal to the square root of 21. VF is equal to, mathematically, it's going to be plus or minus the square root of 21. And that's going to be second square root 21. That's going to be 4.58 meters per second. But let's look at our diagram clearly at point D. What is the vertical velocity at point D, which is 3 meters above the board? Oh, actually, I must apologize. Point D could be here, or point D could be there. If point D is on the way up, then it would be plus 4.58 meters per second. And if point D is on the way down, then this would be minus 4.58 meters per second. I think by my diagram, I think D is on this downward track. So I think it's fair to say that VF at D is equal to minus 4.58 meters per second, because by inspection from my diagram, point D is on the downwards track. It's not on this side, it's on that side. So I think it actually is fair enough to be able to recognize that VF at D is going to be minus 4.58 meters per second rather than plus 4.58 meters per second. So a number of skills there, some of them answered by conceptual, some of them answered by using equation.